Hello friends, how are you? Today I am going to talk about differentiation and differentiation by first principle. Suppose we are having a function y equals to f of x. F of x means any function like f of x equals to x square, f of x equals to sin x, f of x equals to log x, f of x equals to root x, f of x equals to under root of something like anything, whatever it may be. F of x equals to e raised to x. So y is any function f of x. Now we will define dy by dx by first principle. Suppose you are having y equals to f of x and dy by dx by first principle defined as dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h. This is the basic definition of differentiation and it is called first principle, differentiation by first principle. Let us understand this principle by taking one example. First example, suppose y equals to f of x equals to x square. Find dy by dx by using first principle. So let f of x equals to x square, f of x plus h equals to x plus h whole square. What is h? H is an increment in x value, which is a very small increment. Now by definition of dy by dx, by using first principle, limit h tending to 0 f of x plus h minus f of x upon h. So limit h tending to 0. What is f of x plus h? That is x plus h whole square minus f of x, that is nothing but x square upon h. This is equals to limit h tending to 0 x square plus 2xh plus h square minus x square upon h. What I have done here? I have expanded it by using a plus b whole square formula. So now dy by dx equals to limit h tending to 0. Here x square cancelled. We get here 2xh plus h square upon h. Now we will take h common in numerator. So 2x plus h upon h. H get cancelled. And so we get limit h tending to 0 2x plus h. When we put the value of h, then it is called applying limit. Now applying limit. So wherever the h is there, you put 0. So we get here the 2x. Therefore how to write? Differentiation of x square with respect to x equals to 2x. What we done just now is nothing but differentiation by first principle. Let us have one more example. We are having y equals to f of x equals to x cube. Find dy by dx by using first principle. Step number 1. F of x equals to x cube. F of x plus h equals to x plus h whole cube Now definition of dy by dx. Dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h. So equals to limit h tending to 0 x plus h whole cube minus x cube upon h. How x plus h whole cube has come? Because f of x plus h equals to x plus h whole cube. Therefore, in place of f of x plus h, we are putting x plus h whole cube minus f of x. F of x nothing but x cube. Now we'll open the bracket. Here is the limit h tending to 0 x plus h whole cube. How to write it? Write here x cube, write here h cube. I am giving one easy idea. Write here 3, then x square h, and write here x h square plus, this is a x plus h whole cube minus x cube upon h. So limit h tending to 0, x cube get cancelled. We get 3x square plus 3x h square plus h cube upon h. After that, what you do? 3x square h it is. So we can take limit h common. So we get 3x square plus 3x h plus h square upon h. H get cancelled. So what do you get here? Limit h tending to 0, 3x square plus 3xh plus h square, applying limit, putting the value of h equals to 0 in this expression is called applying limit. So wherever the h is there, put 0, that is equals to 3x square plus 3x into 0 plus 0 square. Therefore dy by dx equals to 3x square. So finally, how to write down? Differentiation of x cube with respect to x equals to 3x square. Let us have one more example. Suppose y equals to f of x equals to sin x. Find dy by dx by using first principle of derivative. Solution. First of all, f of x equals to sin x, then f of x plus h equals to sin x plus h. Dy by dx, definition of dy by dx nothing but limit h tending to 0 f of x plus h minus f of x upon h equals to limit h tending to 0. What is f of x plus h? Sin x plus h, and minus f of x, that is sin x upon h. Now we will use trigonometry formula, that is sin c minus sin d equals to 2 cos c plus d by 2 and sin c minus d by 2. Therefore sin x plus h minus sin x equals to 2 cos x plus h plus x upon 2 sin x plus h minus x upon 2. This is equals to 2 cos cos 2x plus h by 2 dot sin x and x get cancelled, h by 2 here Therefore limit, that is dy by dx, therefore dy by dx equals to limit h tending to 0. Now put the value of sin x plus h minus sin x, that is nothing but 2 cos 2x plus h by 2 sin h by 2 divided by h. Therefore dy by dx equals to limit h tending to 0 to cos 2x plus h by 2, and here limit h by 2 upon h. We rearrange the terms, and after that multiplying and dividing by 2. So dy by dx equals to limit h tending to 0 to 2 cos 2x plus h by 2. 1 by 2 is outside, and sin h by 2 upon h by 2. Dy by dx equals to, now this 1 by 2 is written at the beginning, and this 2 also written at the beginning. Now separating the limits, limit h tending to 0 2x plus h upon 2. Separating means applying limit individually. Here limit h tending to 0 sin h by 2 upon h by 2, and we know that limit theta tending to 0 sin theta upon theta equals to 1. This is the formula taken from limits. Therefore dy by dx equals to, these two to get cancelled, limit h tending to 0 cos 2x plus h by 2, and by formula it becomes 1. Now applying limit to remaining part, so cos 2x plus 0 upon 2 equals to cos 2x upon 2, 2 to get cancelled. Therefore dy by dx equals to cosx. How to write it? Differentiation of sin x with respect to x equals to cosx. Now let us move to the next example. Now we'll find out dy by dx of cosx by using first principle. So let f of x equals to cos x. F of x plus h equals to cos of x plus h. Dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h. Dy by dx equals to limit h tending to 0 cos of x plus h minus cosx upon h. Now let us revise formula for cos c minus cos d. Cos c minus cos d equals to minus 2 sin c plus d by 2 dot sin c minus d by 2. Therefore, dy by dx equals to limit h tending to 0 minus 2 sin x plus h plus x by 2 dot sin x plus h minus x by 2 whole divided by h. So dy by dx equals to limit h tending to 0 minus 2 sin 2x plus h by 2. This cut down sin h by 2 upon h equals to limit h tending to 0 minus 2 sin 2x plus h by 2 and sin h by 2, and this h can be written below sin h. So here is the h. Next step, limit h tending to 0 minus 2 sin 2x plus h by 2. Here sin h by 2 multiplying and dividing by 2. So limit h tending to 0 minus 2 sin 2x plus h by 2, 1 by 2 taken outside, sin h by 2 upon h by 2. So limit h tending to 0 minus 2 upon 2 sin 2x plus h by 2 and sin h by 2 upon h by 2. This 2 get cancelled. Now taking limit to each term, here also limit sin h by 2 upon h by 2. Now applying limits, so sin 2x plus 0 upon 2, and here is by formula it is equals to 1. It is a property, limit theta tending to 0 sin theta upon theta equals to 1. By that property we got second bracket equals to 1. Now sin minus is already there here. I had forgotten to write, now I have written. So 2x upon 2, 2 to cut down, so minus sin x. Therefore differentiation of cos x with respect to x equals to minus sin x. Next example, if y equals to tan x, find dy by dx by using first principle. Step number 1, as usual, f of x equals to tan x, f of x plus h equals to tan of x plus h. Now dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h dy by dx equals to limit h tending to 0 tan of x plus h minus tan x upon h dy by dx equals to limit h tending to 0 tan x plus h can be written as sin x plus h upon cos x plus h. If your trigonometry is not strong, I have so many videos on trigonometry. Visit my playlist on trigonometry and go through it. Sin x upon cos x upon h limit h tending to 0 cross multiplication sin x plus h cos x minus sin x cos x plus h upon cos x plus h cos x and upon h. So limit h tending to 0. This is a sin a cos b cos a sin b. So sin a plus b sin a minus b upon cos x plus h cos x and h divided by h limit h tending to 0. This and this cut down 1 upon cos x plus h cos x and sin h upon h limit h tending to 0 1 upon cos x plus h cos x limit h tending to 0 sin h upon h. Now applying limits 1 upon cos x plus 0 into cos x, and here is by formula it is equals to 1, that is 1 upon cos x into cos x equals to 1 upon cos square x. Therefore differentiation of tan x with respect to x equals to sec square x. Next example, if y is equal to cotx, find dy by dx by first principle. Step 1, y equals to f of x equals to cotx f of x plus h equals to cot x plus h. Now by definition of dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h. Dy by dx equals to limit h tending to 0 cot x plus h minus cot x upon h equals to limit h tending to 0. Cot theta nothing but cos theta upon sin theta. Therefore cot x plus h upon sin x plus h minus cos x upon sin x upon h on cross multiplication cos x plus h sin x minus cos x sin x plus h upon sin x plus h sin x and h. Therefore dy by dx equals to limit h tending to 0, writing properly, sin x cos x plus h minus cos x sin of x plus h upon sin x plus h sin x and h upon h. This formula resemble with sin A cos B minus cos A sin B, where A equals to x and B equals to x plus h. Therefore dy by dx equals to limit h tending to 0. This formula sin A cos B minus cos A sin B equals to sin of A minus B. Therefore dy by dx equals to limit h tending to 0 sin of A minus B. A nothing but x and B nothing but x plus h upon sin of x plus h sin x divided by h. Therefore dy by dx equals to limit h tending to 0 sin of x minus h upon sin x plus h sin x and h here, x cut down, dy by dx equals to limit h tending to 0 sin of minus h upon h into 1 upon sin x plus h into sin x. Dy by dx equals to limit h tending to 0 sin of minus theta equals to minus sin theta. Therefore minus sin h upon h, this is the first part, and limit h tending to 0 1 upon sin x plus h sin x. If your trigonometry is not strong, then go through my videos. On this channel there is a playlist of trigonometry. In that playlist there are many videos related to trigonometry, so go through them and make your trigonometry strong. So applying limits, and this first part becomes minus 1 and second part 1 upon sin x plus 0 into sin x, that is minus 1 upon sin x multiplied by sin x equals to minus 1 upon sin square x, which is nothing but equals to minus cosec square x. Therefore, differentiation of cotx with respect to x equals to minus cosec square x. Next example, if y equals to secx, find dy by dx by first principle. F of x equals to secx, f of x plus h equals to sec x plus h, dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h equals to limit h tending to 0 sec of x plus h minus sec x upon h equals to limit h tending to 0 1 upon cos x plus h minus 1 upon cos x upon h, limit h tending to 0 cos x minus cos of x plus h upon cos x plus h cos x upon h. Now cos c minus cos d equals to minus 2 sin c plus d by 2 sin c minus d by 2. This is a trigonometric formula. Applying this one, limit h tending to 0 minus 2 sin x plus h upon 2 sin x minus x plus h upon 2 divided by cos x plus h cos x into h. Therefore, dy by dx equals to limit h tending to 0 minus 2 sin 2x plus h upon 2 sin of minus h upon 2 divided by cos x plus h into cos x, and here is a upon h. Now sin of minus theta equals to minus sin theta. Therefore, sin of minus h by 2 equals to minus sin h upon 2 dy by dx. Therefore, dy by dx equals to limit h tending to 0 minus 2 sin 2x plus h upon 2 minus sin h upon 2 divided by cos x plus h cos x, and here is a h. Now here is a minus, here is a minus, and they are getting multiplied. Therefore, minus into minus equals to plus. So both the minus will go away, and in that place the plus will come. Therefore, dy by dx equals to limit h tending to 0 plus 2 sin 2x plus h upon 2 divided by cos x plus h cos x. This is the one group, and limit h tending to 0 sin h upon 2 divided by h. This is a second group. Now multiplying and dividing by 2 here. So dy by dx equals to limit h tending to 0 to sin 2x plus h upon 2 divided by cos x plus h into cos x, and here 1 by 2 taken common, and here is limit h tending to 0 sin h upon 2 divided by these two, and these two get cancelled. Now applying limit, so we get sin 2x plus 0 upon 2 divided by cos x plus 0 cos x, and by formula the second bracket becomes 1 equals to dy by dx equals to sin 2x upon 2 upon cos x into cos x. Here these 2 and 2 get cancelled, therefore dy by dx equals to sin x upon cos x. This can be written as 1 upon cos x into sin x upon cos x. Therefore dy by dx equals to secx into tan x. Therefore derivative of, that is the differentiation of sec x with respect to x equals to sec x into tan x. Now y equals to cosec x. Find dy by dx by using first principle. So y equals to cosec x. Let us say f of x equals to cosec x, f of x plus h equals to cosec x plus h dy by dx equals to limit h tending to 0 f of x plus h minus f of x upon h equals to limit h tending to 0 cosec x plus h minus cosec x upon h. Now cosec theta can be written as 1 upon sin theta. Therefore dy by dx equals to limit h tending to 0 1 upon sin x plus h minus 1 upon sin x divided by h. Next step, dy by dx equals to limit h tending to 0 sin x minus sin of x plus h upon sin of x plus h into sin x upon h. Now sin c minus sin d equals to 2 cos c plus d by 2 and sin c minus d by 2. Applying this formula, so dy by dx equals to limit h tending to 0 2 cos x plus h upon 2 sin x plus x minus x plus h upon 2 whole divided by sin of x plus h sin x and upon h. Now dy by dx equals to limit h tending to 0 2 cos 2x plus h upon 2 divided by sin x plus h into sin x, taking this as a one group, and sin of minus h by 2 upon h as a second group with a limit h tending to 0. Now dy by dx equals to limit h tending to 0 2 cos 2x plus h upon 2 divided by, this video is for concept building, therefore I am not doing shortcut, I am doing all the steps. Otherwise we can do shortcut as well as, but I am trying to do as maximum step I can do so that your concept will become clear. Once your concept clear, you can do shortcut as well as. Now sin of minus theta is minus sin theta, so limit h tending to 0 minus sin h upon 2 divided by h. After that, here multiplying and dividing by 2, so dy by dx equals to limit h tending to 0 2 cos 2x plus h by 2 divided by sin of x plus h into sin x, and here is minus 1 by 2 taken outside, and limit h tending to 0 sin h by 2 upon h by 2. These two and these two get cancelled. Applying limit, dy by dx equals to, wherever the h is there, put 0 upon sin x plus 0 into sin x, and this minus 1, and by formula the result of the second bracket equals to 1. So here is cos 2x upon 2 divided by sin x multiplied by sin x, and this minus is written here, and these two and these two get cut down. Therefore dy by dx equals to minus cos x upon sin x into 1 upon sin x, that is equals to minus cotx and cosec x. Therefore differentiation of cosec x with respect to x equals to minus cosec x cotx. In maximum books cosec x is written first, therefore here I have written cosec x first. Finally differentiation of cosec x with respect to x equals to minus cosec x cotx. Next example, if y is equal to e raised to x, find dy by dx by using first principle. Step 1, f of x equals to e raised to x, f of x plus h equals to e raised to x plus h. Now dy by dx equals to limit h tending to 0, f of x plus h minus f of x upon h equals to limit h tending to 0, e raised to x plus h minus e raised to x upon h, that is limit h tending to 0, e raised to x into e raised to h minus e raised to x upon h. Now limit h tending to 0, e raised to x is taken common, e raised to h minus 1 upon h. Therefore dy by dx equals to e raised to x taken outside and limit h tending to 0, e raised to h minus 1 upon h. We know that limit theta tending to 0, e raised to theta minus 1 upon theta equals to 1. Therefore dy by dx equals to e raised to x into 1 equals to e raised to x. Therefore finally differentiation of e raised to x with respect to x equals to e raised to x. If y equals to a raised to x, find dy by dx by using first principle. Steps are as usual. Dy by dx equals to limit h tending to 0, a raised to x plus h minus a raised to x upon h equals to limit h tending to 0, a raised to x, a raised to h minus a raised to x upon h equals to limit h tending to 0, a raised to x common, a raised to h minus 1 upon h. So dy by dx equals to a raised to x limit h tending to 0, a raised to h minus 1 upon h. This limit is nothing but log a to the base e. Therefore differentiation of a raised to x with respect to x equals to a raised to x log a to the base e. If y equals to f of x equals to log x to the base e, find dy by dx by using first principle. Step number 1, f of x equals to log x to the base e, f of x plus h equals to log x plus h to the base e, dy by dx equals to limit h tending to 0, f of x plus h minus f of x upon h equals to limit h tending to 0, log x plus h to the base e minus log x to the base e upon h. So dy by dx equals to limit h tending to 0, 1 upon h into log x plus h upon x to the base e. We know that log a to the base e minus log b to the base e equals to log of a upon b to the base e. Therefore, by using this formula, we got that step. Now dy by dx equals to limit h tending to 0, 1 upon h log of x upon x plus h upon x to the base e equals to limit h tending to 0 log 1 plus h upon x to the base e, and before that 1 upon h already present. So dy by dx equals to limit h tending to 0 log 1 plus h upon x to the base e. Here we can write whole raised to 1 upon h. This is equals to limit h tending to 0 log 1 plus h upon x to the base e, and the index is there. In the index, multiplying and dividing by x into 1 upon h equals to limit h tending to 0 log 1 plus h upon x whole raised to x upon h into 1 upon x to the base e equals to now dy by dx equals to log 1 plus h upon x whole raised to x upon h whole raised to 1 upon x to the base e equals to, here was the limit is tending to 0. Now that limit can be taken here, limit h tending to 0 1 plus h upon x whole raised to x upon h whole raised to 1 upon x. But limit h tending to 0 1 plus h upon x whole raised to x upon h equals to e. Therefore, dy by dx equals to log e raised to 1 upon x to the base e equals to 1 upon x log e to the base e equals to 1 upon x into 1. Therefore, dy by dx equals to 1 upon x. Therefore, differentiation of log x to the base e with respect to x equals to 1 upon x. If y equals to f of x equals to 1 upon x, find dy by dx by using first principle. Dy by dx equals to limit h tending to 0 1 upon x plus h minus 1 upon x upon h. Here I have done so much shortcut. Now you are aware of the step. Therefore, x minus h upon x plus h into x, and upon h is there. So limit h tending to 0 minus h upon h into 1 upon x plus h into x. This gone now. After that, applying limit, therefore minus 1 upon x plus 0 into x equals to minus 1 upon x square. Therefore, differentiation of 1 upon x with respect to x equals to minus 1 upon x square. That's all for the day. I hope your concept regarding differentiation by first principle are very much clear now. If not clear, please communicate with me on my email address provided in the description box. Don't forget to subscribe my channel and forward to your friends so that many other students will also learn the differentiation. Now, I will come with another video another time. Till then, wish you good luck. All the best.